So here, we have seen in the previous video the slope of a line. So we have some idea as to what that is. And now, once we know the slope of a line, we are ready to get an equation of the line. Now, there's more than one way to do that. Namely, here, if you have an equation, if you have the slope of a line, and if you know a specific point on that line, you can get an equation of the line using what's called the point-slope form of an equation of the line. So basically here, the slope, I'm underlining it, is m. The point here, x1, y1, that's just an arbitrary point. That's just a certain point on that line. And basically now, once we know those two, we know the slope and we know the point on the line, then we are ready to write down an equation of the line. In other words, if we were to sketch the graph of this equation, we would get the line with slope m that passes through this point. So as an example, the first line that we graphed in the previous video, the line that went through these 2 points, let's find an equation of that line. Well, we calculated the slope to be 2. We did that in the previous video. So now let's get an equation of that line. So what I'm going to do, I'm going to use the first point, 1, 2. So in this case, if I were to use the point 1, 2, I would have y minus 2 equals 2. 2 here, this 2 is the slope, times x minus 1. Y minus the y coordinate, y minus the y coordinate equals the slope 2 times x minus the x coordinate. Now, of course, I didn't have to use the point 1, 2. I could use 2, 4 if I wanted to. In that case, if I were to use that, an equation of the line, the same line would be this. Y minus 4 is 2 times x minus 2. Again, you have y minus the y coordinate equals the slope 2 times x minus the x coordinate. Now, even though the equations look different, their graph, these are equations of the same line, okay? I'm just using different points in each case. All right, now what I'm going to do is move on to this example. So in this case, we're given an equation in point-slope form of the line. We want to graph that line. Okay, well, basically here, we just want to get 2 different points on the line and then connect them. So if I take, for instance, x to be, 3, then we have to calculate y. Y minus 1 we get is 5. If I substitute 3 for x, I get 3 minus 3, which is, of course, 5 times 0, which is 0. So we have y minus 1 is 0. Okay, so just solving for y, right? You add 1 to each side. Y is equal to 1. And so the point is 3, 1. This is a point on the line. But we need another point. Well, let me take x to be 4, let's say. 3 and 4, I'm choosing kind of randomly, so to say. You could choose any x you want. So in this case, we have y minus 1. That's 5 times 4 minus 3. So the 4 I plugged in for x. We have 5 times 1, which is 5. So we have y minus 1 is 5. So just like before, solving for y, right? You add 1, these cancel. We get y is 6. So now the point 4, 6 is on the line. So now let's sketch that. I know I don't have much room here, so bear with me. 0, here's 1, here's 2, 3, and 4. See if I can make this work. 1, 2, 3, 4. This is our x. 5, 6. Okay. So now just to make it easier, let me take this x equals 4. I'm going to move it over here. So now our points are 3, 1. Then we have 4, 6. Approximately. Let me use a different color. So the graph's going to look something like this. Okay, I know it's not the best, but again, I'm just demonstrating how you can draw a line if you have an equation of the line in point slope form. Again, you just get two different points on the line, plot the points, and then connect them. That's what it boils down to. All right. Now, here we have the slope-intercept form. This one you might have seen in high school. I don't know if you haven't seen it or you have seen it and don't remember it, that's fine. And what I'm trying to say here is slope-intercept form is actually a special case of point slope form. It's what you get when you choose this point on the line, the point whose x-coordinate is 0. In other words, the point where the line crosses the y-axis, hence the name y-intercept. So this is the slope-intercept form. The slope-intercept form of an equation of the line where the slope is m and we know the y-intercept is b, that's going to look like this. So as a quick example, here's y equals 2x plus 1. So okay, but now we're going to graph that line. Well, just like before, we need 2 points on the line. Okay, so if we take x to be 0, you can kind of expect this. We would get y to be 2 times 0 plus 1. That's 0 plus 1, which is 1. Now, so that tells us the point 0, 1 is on the line. If I take x to be something else, say, I don't know, 1, then we have y is going to be 2 times 1 plus 1. Okay, so what is that? That's 2 plus 1, which is 3. So in this case, our point 1, 3 is on the line. So just like before, we plot the points, and then we connect it. We have 0. Here's 1, 2, 3, and that's our y-axis. Here's x. This is 0, 1, 2. So we have 0, 1, 1, 3. And now we connect. And notice I'm putting arrows on the end of the line. It's always good to do that. But this is the line that we get. The line whose equation is y equals 2x plus 1. Okay.